Hello, can you hear me? Only a little bit? Okay, I'll try to speak up. So I learned a new German word last week. I think maybe this is torchless panic, but I don't know. Someone speaks German, maybe. Anyway, but it means the fear of time running out. And the reason I learned this word is because of this tweet right here. So 15 days ago, I realized I was still on the fence about exactly what I was doing for this talk. I knew broad strokes, right? And then I realized, right, oh, that's not very long. So this gentleman helped me learn the German word. Joe didn't know a good word, but he had a good solution, which was just waste 14 of the 15 days. Of course, I'm I tend to plan pretty hardcore for things, but this time that's basically what I did. So I've missed most of this conference because I finished my slides 30 minutes ago. But the talk was mostly done 3 days ago, idea-wise. Anyway, so in this talk, I'm going to walk through a brief introduction of Phoenix and Elm, intro to the Firestorm Forum, which is an open source Phoenix-based forum, and sort of how it's built. I'm going to discuss how Elm and Phoenix interact in this particular case or in general. And I kind of found a neat communication style that I don't know if it's novel, it's new to me, that sort of came out, and it's a simplified way of interacting with my backend. And so I wanted to show it off and talk about a few consequences of it. So first off, brief introduction to Phoenix. Who is familiar with Phoenix here? This will mediate how much time I spend here. Who's really comfortable with Phoenix? Okay, so we can zoom through this mostly. So here are some reasons I think that people ought to care about Phoenix. If you have data in a database of some sort, Ecto is really nice. It's not technically part of Phoenix, right, but it's relevant. And then chain sets, which are also in Ecto and maybe shouldn't necessarily be. They're nice for modeling your data, whether or not it's in a store, and then describing how to turn it into something for the browser or turn it into something from a user. So they're very nice, even if you're not in the web piece, actually. Phoenix 1.3 is in the process of coming out. We're at release candidate 1 or something, 2. Anyway, second release candidate, I think. And it made things a lot better. It adds these context things. I won't go into them too much, but it's sort of the domain-driven design-bounded context idea, so that your controllers basically shouldn't be doing database operations anymore for the most part. This is nice because you're modeling your app and you're modeling your web piece, and they're different. And that's a thing that it bothers me that we don't do enough. Anyway, so it's great that Phoenix is making that good. It also added first-class umbrella application support, which is also nice because less fiddling. And then Phoenix also gives us channels. Channels are amazing. They're really good abstraction for real-time communication. They don't have to be WebSockets, so don't confuse the two. But and they also give you knowledge of presence on a given channel, whatever that means, or a given topic by particular users. So I'm going to go through some basic Phoenix code examples. Here's an example schema. So if you haven't seen Phoenix before, or Ecto before, and this is maybe the smallest font on any of my slides, so I hope it's not terrible. But basically this says, it sort of lays out ultimately a struct for category. It says it should be backed by the categories table. And you can do things like find child categories or find the views, so people have viewed this category a certain number of times. This is not exciting. This is just nice. This is not breaking new ground. One thing that is kind of fun is these two virtual fields, children and ancestors. That just makes it easy for me to get the data and put it onto this struct before I hand it somewhere so that it doesn't have to do math later or database access. Sorry if this is too basic, but it's just nice. And this does not interact with the database. That's what the repo does. This describes how to do the interaction with the database. And this is an example of a controller action. So again, this is just very quick intro to Phoenix and slightly not hello world examples. This is an example of a controller action. It just takes, in this case, an ID or a slug, figures out how it looks it up, prepares this tag category thing, which is just like a command that can add a tag to a category. And then it tries to get a category, and if it found it, it'll show it. It's not. It could be tighter. There are things I could do to make it smaller, but in general, this is pretty clear. So I like this. It's good. And then here's a view. In this case, we're dealing with API, right? So I've just said when I render the fetch views index.json, I have to give it all this stuff, or else I don't pattern match on this function. And then I basically delegate all of them to this other view that knows how to render the entities in my data model. And then there's the router. So like this is almost all the stuff except for channels that you get with Phoenix. This is the router. This, in this case, says like we have a browser. We've added all these plug things. Everybody know what plug is? Plug is awesome. Plug is what this is built on. I'll talk about it momentarily. But all the plugs, in this case, say like, okay, well, let's fetch the session out of the HTTP connection that knows all the stuff in HTTP terms and put it into this like place that it's easier to look at. Get the flash, protect from forgery, put secure browser headers. These are all tiny little functions that are plug functions that you can like put into a pipeline. And then I've added my own, which says, hey, go ahead and get the current user out of however we happen to have it, because I have to handle a complex case if I want to do some squirrely wrong stuff with some tests. Anyway, so that's a place I can hide that complexity. And then we have this thing right here that says like, here's what the web piece looks like. You have all these routes. They map to these controllers, potentially these particular actions. And then that's it. So like, it's your basic routing. I just wanted to show it as the intro thing. And then in terms of plug, this is what it's all built on top of. It's an abstraction for web servers that at the very least supports Cowboy. I think it supports other web servers, but I haven't ever used anything but Cowboy because it's pretty good. Anyway, but it gives you the ability to plug in behavior like you saw before. So like just slot these things in and they happen on the connection. Anyway, it's nice for building like, for modeling what a request handler ought to be. So that's like super basic intro to Phoenix stuff. We'll get into it more, but now I'm going to move on to Elm. Who's heard of Elm before? Who's used it a little bit, at least? Who's used it a bunch? Okay. I've used it for like a year and a half or so now. I've used it in production, doing different sorts of things, and it's awesome, and I love it a lot, and I want other people to use it, because you're going to write software I have to use, and this way it won't be as buggy. That's one reason. It is, in fact, a delightful language for building reliable web apps. I've had maybe 2 runtime errors at all since I started using Elm. One of them was already a known issue, I think. And a runtime error in Elm is a compiler bug. So that's like pretty freaking cool, in my opinion. Like if you get a runtime error, you're supposed to file it as a bug against the Elm compiler. That's awesome. Anyway, so reasons you might care about it. It's functional. Elixir, Erlang are functional. It's very functional. It's strongly typed. There are no runtime errors, and it uses the Elm architecture. Also, it has the nicest error messages you'll ever find. It like just holds your hand and walks you through making that change you tried to make but didn't quite finish. It just does that. I, on another slide deck, have a tweet from John Carmack. So John Carmack tweeted about how every programming language should try to have errors as good as Elm's. So he probably knows things. Anyway, so this is what an Elm application looks like. This is the Elm architecture. That's sort of that last thing I talked about. So the way that this works, just to give you a broad understanding of Elm, this thing in the middle, think of it as the Elm runtime. So every Elm application ships with the Elm runtime that knows how to do certain things, knows how to talk to all the browser APIs, knows how to do anything that's impure and like do that for you. Because when you write an Elm program, you write a pure program. There's no side effects at all. So what you start off with is you describe kind of like what your model is. Or there's various ways to start, but your model is like the data that you need to show the stuff, right? That's all that means. So you describe what that is, and then you would describe messages. Messages are like the things that people can do. So those are both really easy concepts to understand. And so you literally just make a union type, like a list of the things people can do. And that's it. That's all the things people can do in your app, and you have to handle all of them. From there, you start off with like this init. So init would like give your initial model. So maybe it's just like 1 in the event of a counter, and you just want to start at 1 all the time. But maybe it looks, maybe before you load up your Elm app, you look into local storage and like fetch your serialized version of the model, and then you like decode that, and that's what you hand to the init model. So anyway, that's the sort of thing you could do up there. Anytime something happens in your application, update gets called. And so again, all the green things you are describing, these are functions that you define these, you built an Elm application. So update, it gets the message and it gets the current model handed to it from the runtime anytime a message is emitted, and you just return a new model, and then this is a 2-tuple of a model and then a command that is of type message. And so basically, if you ignore the second part of the tuple, this is like just any old gen server with handle cast, right? This is a thing, and you cast messages, and if it knows about the messages, it does stuff and returns the new model, right? This is exactly gen server. The second bit, though, is the command message part. That's the cool part, because that's where you say, like you describe all the stuff that, like, gosh, it'd be nice if somebody would go make this API call, but you don't do it because that's impure, right? So you just kind of like bundle it up and like, if somebody would just do this thing and then tell me how it went using one of these two functions, like that'd be super cool. And then the Elm runtime like takes it, and then it goes and does that because it'd be cool of it, and then it gives it to you. So that's where all the impurity lives, is you hand it to the runtime and it does stuff. So the benefit is you get to write pure programs. And then we have the other two bits. There's the view. Again, this is a function it takes as an input the model, and it produces some HTML that could or could not produce messages. And so this is just a function. You just get some data, and then like you emit one structure, and you're done. And then you have subscriptions. This is anything in the outside world that might happen. So one would be the ticking of time, right? Again, remember, we're pure, so we can't say like, do this function, and like in the middle of it, go get the time, because that's impure, right? So, and purity, if you're not clear, just means like if I call the function with the same arguments, I get the same return back, right? There's, like, you can't do anything that doesn't involve the things you were handed. Anyway, so then subscriptions, like, that's another part of the runtime, where the runtime can like tell you every second. You can tell the runtime like, it'd be nice if you told me when time happened, and the runtime will be like, I got you. But you can also do other things here. You can do things like WebSockets or channels, Phoenix. And that's actually very cool, and we'll come back to it, and maybe I'll come back here for this image when I talk through it. Or maybe I won't talk through it now. Okay, so this is like how Elm works in general. If you have any questions, do talk to me later. I know there's a million different ways to try to show this diagram. This is the one I like the most. So let's look at what Elm actually is, though, right? We'll build a basic Elm app. There's apparently a shortage of counters, and the Elm community has set out to correct this wrong. So we're going to make one. Also, it just happens to be a really good example for an Elm app. So I mentioned before we define the message in the model. That's kind of how I start. So I define my model. It's just an integer. It's a counter. There's a number. Done. And then things you can do, right? You can increment it or decrement it. You can imagine being able to increment by 3 or something, right? Maybe that's a different message. Maybe that's a message with a parameter. But this is the universe of things that you can do in this application. So like increasing the font of the number is not in the universe of things you can do in this application. And if it were, you'd kind of see that right here. So here's our update. It gets our message in our model, and this is a slightly more basic version of an Elm application, so it doesn't do anything that's side effecty, so you don't return a two-tuple, you just return the new model. So now it very much is just gen server with only cast and no side effects. And so here we get a message. If it was decrement, we'll return our model -1. If it was increment, return our model +1, right? That's it. One sort of neat thing to note, every Elm function is a single expression. So like it's not like you give it these 3 functions you want to run one after the other. You give it an expression. And then there are ways to do the things that make you think that you need imperative stuff. And then this is sort of the view, right? So our model, remember, is just an integer. So we have a function that takes an integer, and it produces, here I'll show like what Elm HTML stuff looks like. So you have like an HTML tag like div or button, and each of those takes 2 arguments. It's a function that takes 2 lists. The first is a list of attributes, and the second is a list of children. And they both have to be parameterized on the same thing that this thing is, or mapped appropriately. So in this case, we have a div with no attributes, so like no class, no ID. Inside of it, we have a button. When you click it, it'll decrement, so that's one attribute. It's like an on-click. And then it has one child, which is a text node that has a minus sign. Then we show the number. Then we have the increment button, right? I think it's fairly easy. I think I spent way longer explaining it than it took anyone to read it and sort of figure out what was going on. Anyway, so that's kind of the intro to Elm and Phoenix at a very high level for both of them. And we'll dig into we're going to skip the intermediate and move on to just showing like this neat thing. But if anyone wants to talk about like the intermediate stuff, there's other stuff I'm glad to discuss. Brief marketing aside, I dropped out of my consultancy 1.5 years ago because I wanted to like focus on this thing, which is whether I'm good at it or not, I want to help people become better developers, partially out of just goodwill, but honestly, I'm a super selfish person, and there's some software developer who's going to write the software for my pacemaker, and I would prefer to do whatever I can to have that not be written in JavaScript. So that's part of this. The other part is I think that it's just fun, and I think that if we can help other software developers get better, it's going to have a bigger impact than any one like thing that I might spend 3 or 4 hours doing. So that's done at dailydrip.com, where we do daily continuing education for developers. We have a lot of Elm and Elixir content, React Native, R, Ember, Swift 3, lots more stuff coming. And if you want to get better at like building software, or at least tell us why we're not good at teaching people that, then like you could check us out for either purpose. And also, we're actually going to be, we've just now switched to doing a thing where we're kind of becoming like a research and development arm of like fun things to look at for our subscribers. So we are now like community driven. So we have a section of the site where people can propose and upvote and downvote things. So like people can just decide what we're going to do episodes on. And we've already gotten like a couple of interesting ideas, and we hope to get a lot more from that than just like, here's the cool stuff that I want to show. Rather it be like, here's the stuff we all agree is very cool. Anyway, so that's Daily Drip. That's the end of the marketing aside. Let's talk about Firestorm. Firestorm is the open source Phoenix-based forum with an Elm front end. We did a Kickstarter for this, and it went very well. Very, very happy about it. So we raised $23,000-ish, slightly under, which means that we hit our first stretch goal, which means that this forum is also, after it hits 1.0, we're going to have a like a Slack bot for it. So, you know, full-on production forum. The dream is, like the whole idea behind this thing was a few things. We're going to build a production app just like I would have done at my consultancy for a client. We have a professional designer working on it. She already works for us, and she wasn't fully busy, so it seemed like a good thing to do. We're going to do continuous integration, continuous deployment. And honestly, it's just hard to find like an example application that's out there in the wild that is doing all this stuff, just because typically that, you know, most open source projects aren't doing continuous integration because they probably don't even host it, right? It's just some software you can use. So we have an alpha release. We've been sorry, we're not at alpha. We're almost at alpha release, 2 features left. We've been dogfooding it at this firestormdogfood.herokuapp.com. I don't know if this green is legible. And then we're on github.com/dailydrip/firestorm if you want to see the code. Another part of the Kickstarter was we're producing 5 weeks of free like Elixir content. So intro to Elixir, like intermediate Elixir, or you know, not intermediate, but like, hey, processes rather than syntax. OTP, Ecto, and Phoenix. So like a week on each of those things. We're producing those, and we're about to start week 4. I actually backed off a little bit because it turns out that Phoenix 1.3 was going to finish like shortly after I finished doing a week of episodes on Phoenix 1.2, and that seemed bad. Anyway. So that sort of held us up. But then after we're doing that, we're producing videos that are, you know, premium part of our thing that walk through building Firestorm. So like building from scratch, essentially, this thing that becomes a production application. So that if anyone like has questions along the way, we should have something covering it. So anyway, so since it was an open source project, part of the Kickstarter involved us getting our designer to work on professional designs for the project and weekly meetings to discuss the progress and like feature requests and stuff with our supporters. So we did 10 of those, and now we're moved on to like just sort of open ones every week. So if you want to join like a Firestorm fireside chat, you can do that, and as we talk about the thing. Anyway, but here's the design. So this is like not all implemented here, but this is like a Phoenix app, right? You can log in. It's kind of like an email client or whatever for drilling in. It looks an awful lot like what, Discourse, is that the name of it? But we'll, you know, try to not be a clone. Anyway, so that was just the basic design walkthrough, just to show you how all that went. But now let's talk about the architecture of the actual application. So it's an umbrella app, and it contains 3 applications inside of it. We have Firestorm Data, Firestorm Web, and Firestorm Notifier. And they all do different stuff, right? There's the data piece is literally like the application, right? This is what it means to be a forum, and how do we store that stuff. And then the web is literally just like, how do I talk to people and like then interact with the application for them. And then the notifier just listens to some stuff. So we'll sort of talk about that again very, very briefly. This thing has the actual application logic. It has the data store knowledge. And it also has a pub sub. Right now it's a GenStage producer. That's probably not the best idea. But right now that's what I'm using. Maybe I use Phoenix pub sub in the future. Anyway, but so that other applications can know like what's happening in the data layer. Because you want to be reactive, right? You want to say like, oh, this thing changed. Let's do something. And so pub sub. Then we have the web piece. As I mentioned, it just turns user input into commands and turns like data into JSON or an HTML view or something. And then we have the notifier, and it's a consumer of the GenStage. So it's literally right now all it's doing is listening for new posts that come through the data layer events thing, and it'll just email anyone that's following the thread, right? It's not super smart, but we do expect to put a lot more smarts on there for things like batching up emails, right, for people that don't want an email every time there's a post. But the point is, it's going to be a more broad OTP app, right? It's going to have like little processes that live that are like gathering up emails, and then 4 hours later they die and send their emails or whatever. And then the next little bit is the part actually I end up spending a lot of time chatting about. I don't know what to call it. It started out as an API, and then like the way I've made my LMAP work, and now it's channels. But the LMAP mostly didn't have to change. So I want to talk about this because I think it's neat, and it gave me a lot of insights. And you get to see exactly how like the Elm piece at least works. So it's kind of like JSON API meets GraphQL and then doesn't do anything reasonable. So before we get there, let's just look at like this Elm client for Firestorm. So we've seen basic Elm and basic Phoenix. We don't really see like the advanced Phoenix part, but I'm glad to show code if anyone wants to see it. But let's look at how the Elm client interacts. And before we talk about how it interacts, here's just how like the view for this more production-ready thing looks. So it's just a function. It's just bigger than the other function we saw for the counter, right? It's the same idea. You give it a few more arguments, but it's the same deal. But here you can see, like, if you're looking at it, we have all these like classes, layout content, thread header, item metadata. They're clearly like things, but we're just kind of making them ad hoc as we go. And I've always hated this about templating languages because in some cases it's very hard to like encapsulate little pieces. Anyway, but Elm is not so much that way. So like this worked perfectly fine, but it didn't read that nicely. So we refactored it to this, which I think is better. And Elm makes this super easy. Like literally I just pulled a bit out and like gave it a name, and then did that a couple more times, and then like you're done. And if it compiles, you did it right, and if it doesn't compile, it'll tell you where you did it wrong. So that's really cool. I should have an example slide that shows an error, but I don't. Pardon? Go back and forth for a second. Yeah. So then basically we have this layout content, we have this thread header that's this big section in the middle, then we have this post list. And so then like, cool, we have names for those already. There they are. Anyway, and so the point is when we extract the layout content, here we wanted a function that takes a list of HTML things and produces an HTML node. So I could just take a list and then produce a div and then put that list underneath the div, right? That's a reasonable way to do it. But Elm provides like automatic currying. So really, layout content a div takes 2 arguments, right? It takes the attributes and then the children. So if I want a function that takes children and puts them in this div, I just don't complete this function, right? I didn't give it a second argument. And so this is a function that's waiting on that last argument. That's all this is. It's very straightforward to anyone that's sort of dealt with currying, right? But in other languages, I would like take the argument and then pass it as the third argument because it's easier than this. And because of that, I don't refactor as much in languages like that because it's like, I got to make like a wrapping function because there's no currying. And so it's just not convenient. And so I just put up with it. And I say, no, you know what? This is good enough. But if it weren't for that, I could get to this, which is better. Anyway, and then here, like, I like this little function, right? We did it slightly differently over here. We did list.map, and then we give it a function that it'll map through, and then we give it the posts that it's going to use. And in this version, I take the posts, I map them through the function, and then I pass those to this OL that already has its attributes, and they're provided as the children. Did the same thing. I just like this because it's a transformation the whole way down, right? You have posts, you turn them into HTML, and then you turn them into broader HTML. Anyway. And then thread header, like when in the process of doing this, you'll notice everywhere we have like this class thread dash header. This is like a RSCSS component, rscss.io. If anyone likes that CSS is a thing but has never been comfortable that like their methodology would scale or like run into things and you have like, oh, these 2 things are like conflicting and it's inconvenient to fix and I didn't figure it out till too late. Anyway, if anyone's in that boat, I was in it for a long time. RSCSS, really, really cool. It gives you just a couple of small rules, and then it turns out that stuff is awesome. So these are both RSCSS components, but like I've got them all in this one thing. So at this point, this is last night, I was looking at this, and I was like, it's kind of stupid that I haven't ripped that out as a function either. But like I'm in the middle of writing my slides, why would I do it? But it turns out that Elm is really fast, so we just broke it out into a component because it took like a minute. And now we have these components, and we can reuse them everywhere, and they map directly to like my CSS, which is very neat. This is not so exciting maybe, but maybe it's useful to see like the evolution of like view functions in Elm. Like they go from the basic to like functions that you can compose that are nice. And anytime you do something like this, the compiler helps you. So refactoring is really nice in Elm was the point, and that made it trivial to get to something like this. I changed it slightly. like while I was in the process of writing the slides. And so now we have like this whole components layer in our application that we didn't have 20 minutes before I started this, and it's just nice. And that's like every experience in Elm is like this for me. Like I have a thing, and I'm like, I should do that, but it's probably a lot of work. And then I remember that I'm using Elm, and so it's not a lot of work, and so then I do it, and now my code base is better. And previously I would have just been like, gosh, that'd be nice to do, but let's not yet. Anyway, so the data model for this thing is, this is a part that I wanted to talk about because it just makes me happy. I know that there is at least one person in this room who will say, you know, there's research on this, then you should not do it that way. But maybe not. But this was neat for me. So basically the way that it works is we have this local database sliver. So we keep a section of the data model that you care about, sort of. Now right now I haven't finished all of the stuff. So when I say a section you care about, I mean or that you ever cared about. So it grows hugely. Like it's not smart memory-wise yet, but it's easy to do. So anyway, its model is a record containing a field for each entity type. So we know about categories, threads, users, and posts. So we have like, think of these as like local databases, right? So you have a dictionary with an integer key, and it only holds categories. So like you can never get a thing out of there and have anything that isn't a category. And then the key is just its ID. So we have a dictionary of things we can look up by ID locally that represent the things remotely. And then I have this wants thing, and before I get into that, so what we do, like if I have a category, you might imagine that a category that has subcategories has like a subcategories field that holds a list of categories or a dictionary of categories or whatever. There are a couple of problems with this. First off, if category is an alias, then you can't actually do that because it would be an infinite type. And then there's a way to get around that, but then it's kind of more wordy. You have to like wrap everything in a module and add a bunch of functions. Plus, I don't think it's better in this case, because what I really want to do, I don't want a tree of categories. I want like a category, and I want a database, and that's what I have. So categories know their foreign keys, essentially, right? Even though it's modeled differently on the back end, this category knows all of the topics that belong to it. And so if I want to show the category, I can just look up the topics in my local database. And if I don't have them, I can have a thing that's constantly getting data that I need that I don't yet have. So I get a new category, and it's like, oh, it turns out there's these 3 threads that are underneath it, and like, I don't know what I'm going to do when people ask me to show that, so let's go ahead and fetch it before they do. Anyway, so that's a cool thing that's easy to do with this layout, with this whole like flat, not graphy layout. And then I have this wants thing, and this is a, I call it a replenish request. I think I show it, yeah, I show it right here. So this is just where I give, for each type of thing, I give a list of IDs that like, it would be nice if I knew what these were. Like someone mentioned them, or I have reason to believe they exist because someone went to a route that like ended in 7, so it's a category with ID 7, but I don't know what that is. So I can just put stuff into my model, into this wants, and then I have a thing that looks at it and says like, do I want anything? Because if I do, let's ask for it. And so just by virtue of putting stuff into the model, like I get my local database updated without, once you've wired the pieces together, which is really nice. It's like, it's declarative rather than like making a request, rather than being imperative and being like, hey, give me that category. I just happen to tell my like layer, the store, it'd be cool if I had this, and then I get it. And so that's nice. Like the declarative versus imperative makes stuff way nicer. That's one of the reasons that we do the functional programming thing, I think. And then we have the store update. So in general, like with an API, like a REST API, you might have like a categories endpoint, and it gives you just like your category or a list of categories or whatever. And you might have like a threads endpoint, and it'll give you a thread or like a list of threads or whatever. So all of my endpoints, or all of my anything that I get from the back end has this. So it'll just give me anything it wants to tell me about across any of these entities. So you can imagine me asking for a category, and it knowing, well, you're just going to want those threads as soon as I give this to you, because I know that it has these 2 threads, and I know you're going to ask me for them. So you can like just write some application logic that says, go ahead and give them those threads, and then you'll never, because it's imperative, you'll never hit the request for those 2 threads because you already have them when you go to look. So because of that, this one little change in how I do my model gives me all kinds of flexibility because it's imperative and because I can like give it more than it asked for, and I know that it's going to act right because of the imperative thing ultimately. So this is cool. This was like part of my little realization. It may be stupid. I don't think so. Right now I'm very happy with it. Anyway. And so, yeah, that ultimately, like we send these 2 types to the API, but how do we get them to the API? Like how do we actually interact with an API? So we use this HTTP module. And, sorry, here's a function. This is like the home index function. And it says, get the API base URL's home path, expect to get some JSON that we can decode with a store update decoder. And if that worked, well, whether it worked or not, go ahead and send that out. So up till now, it's what's called a task. So it's like a description that's still malleable of what you'd like to do, so you can chain more stuff. At this point, send turns it from a task into a command. So a command is just, you can't do anything more to it. You can hand it to the runtime at that point. So you can defer this and not do it in your API, or you can do it right here, but you lose flexibility. Maybe not important to tell, felt like it anyway. Anyway, so at this point, it sends it, and then we have this handle get home complete that if we got a store update decoder, like if all the HTTP stuff worked out fine and we received a thing that we could decode as a store update, then we call this tagger function, which takes a store update into a message. If any other problem happened, if HTTP error happened or if it wasn't decodable, we hit this error tagger, which turns an error into a message. And so then when we call this API, like at the call site, we can say, in the event of failure, do this. In the event of success, do this. And by do this, we literally mean just, here's a message that you would emit. Anyway, this is also really nice or important. If you're doing an API, you'll notice that this is like lowercase message. So this means like it can be anything, but those three instances have to be the same thing, right, in type unification terms. Like you're not restricting it to the types of messages that this function can produce. That's really nice with your APIs because you will find places that you didn't think about, and if you've already hard-coded it to like a particular message type that it produces, you end up having a bad time. So if you have a module like this or find yourself building a module like this, just do this. Give it taggers and give it this sort of generic message. Anyway, it gets nice when you have to deal with errors more than anything. So let's look at like what some requests look like in this style from a typical single-page app. So we have this client. Somebody requested, they loaded like /get categories or /category/1. So it knows like, oh, I guess there's this category with ID 1. I'm a client. I don't know anything. So maybe we'll ask somebody about it. And so it says, hey, server, get this for me. And the server's like, cool. We'll look in the database. Hey, I got it. I'll send it back to you. We decode it. Now we have it. So this is cool, but I'll get to another point momentarily, and then we'll probably come back here and look at a few things. And then this is just another API example. This time we're sending something. This is the only reason I wanted to give this. So we have a JSON body, and so we have like this, we give it this replenish request as our first argument, which is like the stuff we'd like. And we have an encoder that knows how to encode a replenish request as JSON. And we just call with JSON body, give it encode replenish request, and give it the replenish request. And like, that'll always work. So that's nice. Just wanted to show it. So I'd like to show you how freaking fast this thing is in practice, because it makes me very happy. So here, first off, is the Phoenix, just the Phoenix application running. Hopefully, yeah, it's all awake. And then I'll go to over here and refresh. This is an Elm application. So the Phoenix application is cool. This is like, you know, the dog food. Oh, it's not up. No, this makes no sense. I need a mirror for this period. Thank you for telling me. But if you hadn't told me, you would have been so rude also. Where's mirror? Arrangement, mirror displays. I know there's some key press. Anyway. Okay. So back to this. This is the Phoenix application. This is the Elm application. You can tell them apart because I didn't put the logo in the Elm application properly. So Phoenix application, we can kind of like troll around, click on things. It's pretty fast. It's not instant. It's not like it's doing too much. It's just, you know, it's not instant. So we click on things, look around. We have some nice things in here like emoji somewhere. Let's see here. I guess actually this is probably maybe the neatest thread because we have like pictures and code. No code in this one. Here's the code. Anyway, so this is just me showing it off briefly just because this is an open source thing, right? It's good. Here's the Elm app. So you've seen me clicking through the Phoenix app and you've seen the speed and it's pretty good. Like I'd be pretty happy with this as a website. So here's the Elm app though. Like I click and then it's there. There's like no load time, right? Because we have everything. Because we know the graph, so we know the things that we could care about later, so we just get them already. And so this works, you know, fine on mobile or whatever. Obviously, it uses a little bit of memory to store the stuff locally, but it's fast. This is like the fastest single-page app I've ever built, and it just makes me happy. And it's not that surprising because we have all the data, but Like this took way less time than me doing something like this in Angular, and also you have to write JavaScript in Angular and all sorts of other things. So anyway, I just kind of wanted to show it off because it's just real fast. It's extremely fast, and it makes me happy. But we're not using the HTTP API right there, so I almost tricked you. Using something very similar. What's happened here? Okay. In theory, I have a, let's see here, go away. Okie doke. Back to the slide deck. Okay, so it is fast. There are a couple downsides. One of them is that we might be too memory intensive on the client, right? Because we're just like gobbling up anything that anybody references, and we're never getting rid of it. So you can imagine that, like for some use cases, this doesn't matter. You're just never going to have enough memory for it to matter. And some use cases, like it's pretty stupid and it's a useless client. Slack is a good example, right? It uses all the memory anyway. So there's some downsides there. Also with the HTTP API, a downside is like, because we're gradually kind of walking our way through this graph of entities, we're making a bunch of requests. So like that was my first implementation, was like it used HTTP to fetch things. And so that's kind of broadly fine, but like oftentimes that means you're opening up a new TCP connection to the server, which takes time, and oftentimes that means that you're sending a bunch of headers, not oftentimes, like basically all the time, except for HTTP 2, you'll be sending a bunch of headers. And there's just like connection teardown stuff that takes time. So like if we want to be the fastest thing in the world, we don't want to do that stuff. So there were solutions. One of the solutions is the API could be smarter. So like you could track this session and know about all the entities that the clients know about, and then only send them. So one of the ways you can be smarter is to send less stuff, right? Even if I ask you for 3 things, if you know that I already have those 3 things, or if I were going to give you some children, but I know that you already have them, once I actually get ready to send them to you, I can like reduce bandwidth by not sending them to you, or reduce database access by not asking for them. So you could do this and like keep all this knowledge on the server of like what everyone knows about. But that's like also going to be taxing when you have a lot of users, right? You're going to use a bunch of memory knowing about that stuff. You're going to use a bunch of CPU like running through it. And even if we did all that and like got all these neat optimizations we could get, we're never going to get real time, like push notification stuff from HTTP. So we moved to channels. We can use channels to make things a lot nicer without changing very much at all on the Elm side. So let's look at how our data is loaded first. So this is my little graph of like how we find stuff out. So remember we did get category /1. So like, cool, this is where I got that category. And so now I know about category 1. But I also know about these foreign keys that it has, like thread ID 1 and 2. And so now I know about these relationships, and I think like I'd like to like know what that data is. And so it goes through this function that maps basically my model into things I wish I knew about. And now we make more requests. We get them. They have foreign keys, right? So cool. Now we know new things we want to know about. So each of these might be an HTTP request. And it could conceivably walk your whole stinking data tree, right? You don't really want to sync your entire database all the time, probably. But still, it's pretty neat. So this is like where you end initially. Doing this with HTTP, as I mentioned, is, oh, those aren't lined up. As I mentioned, is not fast. It's like okay, but it's way chatty. So the interesting thing is this design on its own, though, gives you lots of ability to optimize. So among other things, you could imagine setting a threshold that says, don't go more than 2 layers deep in the graph from where I am to fetch new stuff, right? So that's just a new piece of data you put on your store thing. And then it knows like, oh, well, I want to know about this stuff, but it doesn't come from something that you've asked about recently. So like, I'm not going to go ask for it yet. That's one way to do it. There's a lot of optimizations you can make. I'll get to that in a bit. One of the really interesting optimizations you can make, and here I'm talking about really thinking about garbage collection on the client, like making the client not take a ton of memory. You could encode, so we have like routes, they're types in our Elm application. So we have a type for each possible screen in the application. We have types for all the types of entities. You could encode from a given view which other views you could see, right? Like you can just put data, like make a function that given this view returns a list of 3 views, right? With potential like entity IDs. From a given view, you could also define what pieces of data it needs, right? So this is where you like have the GraphQL thing because views tend to like co-locate with the data they wanted. That's what the GraphQL query is. But you could just like define for a given view and like its arguments, what pieces of data you would need. And from there you could say like, okay, well here's actually this universe of all the stuff that I could possibly need for anything that is 3 clicks away in the application. Like if you just add those 2 things. And so now you could literally like prune your database all the time and just have stuff that is at most 3 clicks away. So like you're just carrying with you this database slice that's just barely big enough that you never have to make a request when you make a view. So that's really cool. But it'd be a bunch of HTTP requests is my point, which is why we did it with channels. And what ends up happening is, if I come back here, I said I was going to come back to this. Okay, hold on. The Elm thing. Oh, goodness, I should have skipped. There we go. Okay, so back to this thing, though. So the way that the Phoenix channels work in our app is you have, you describe all of the, like, the things that you care about, the topics that you want, sorry. So you can map, subscriptions takes a list of your models. Our Phoenix channels are handled in subscriptions. So not a list of your model is an argument. So my model has my store in it. My store has all the stuff that I care about. Like it knows all the entities that I know about. And so from that, I have a straight mapping. All those entities, map them to channels, right? And I feed that into this piece that handles all the tear down and tear up of, or setup of topics on my Phoenix channels, on my socket. And so now, just by putting stuff in my store, I will get updates from Phoenix over channels. Just by virtue of them being in my store, that means that this will, the function from my model to my channels will just update, right? Because that's how it works. And then what's called an effect manager on the Elm side just handles it all for me. So like literally by putting things in my local sliver of a database, I always get updates. Like as long as I broadcast them from the server, anything in my local database is just like updated. So like again, I can do another example. I should have done this while I was mirrored earlier, but I didn't remember. So I was mentioning it being fast. Let's do this. Let's go to the trolling. Let's go to the test thread. And they're in different orders, but that's not terribly important. So again, this is the Phoenix app. This is the Elm app. I'm just going to reply to this thread and say Erlang factory demo. Okay, so I'm going to click reply. I'm going to click it now. And so it updated on the right side instantly. In this particular case, they came up about the same time. Outside of this Wi-Fi, basically, you always see the channels version before the one that made the request ever comes back. It's just fast. And I didn't have to do anything to say, like, tell me about this. Just by virtue of knowing about this thread, I get updates. And one of those updates is there's a new post in the thread. And so that was very cool to me. This is the pinnacle of why I think that it took a long time to get here. This is why I think that Elm and Phoenix work really well together, because I've done imperative setup of channels an awful lot in just straight up JavaScript. Does anybody do channel stuff right now? Has anybody got it to the point that you can have a declarative description of the channels you care about and then like you just get them? I don't even know how I would do it without building something complicated sounding. So the fact that I can just do it and not have to work through that is really cool. So this is like why I think that Phoenix and Elm are so good together. It may not be what you were expecting from the talk, but that's it. There's a few more things to go through, so let me do this quite a bit again. How long do I have left? How long do I have left? 2 minutes. A few minutes, okay. So I'll go through really quick so we can have questions. So somebody asked me why not use GraphQL, and the best answer I had was, I dream of one day building a company that gets sued by or sues Facebook. And their patent grant means that they can take GraphQL, at least their software, away from you if you sue them. So that's enough. Anyway, dream big. So I was talking with Oliver Strolls Barnes. He's a friend of mine on the Elm. He's also on the Elixir Slack. And we were talking about, he's building something very similar to this. We sort of came at it independently, but we ended up with something very similar. And I just was mentioning to him, like, the decision on how I stored that slice of the database and how to do the store updates, led to so many things that I just realized were very cool designs just by their simplicity and I could optimize around. And he said this, he said, Elm is so simple that it guides you to solutions. And this is sort of what he's been saying about his own solutions, right? Because as he just comes up with a thing and like writes one piece of the function he wants, the compiler kind of is like, just hold your hand. And there's somebody else that said something very similar to that. says, although a language can never teach a programmer what constitutes a well-designed program, it can guide him into thinking about the right things. This is from the early 70s from Barbara Liskov. We just had a Papers We Love remote meetup. If you like papers, you should join those with us every month-ish. But this is like the reason that I like Elm as much as I do. But it's hard to remember this off the top of my head when someone asks me. I'm just like, oh, purity or currying. But it's the fact that like it makes me build good software. Anyway, so use Elm with Phoenix. It's a good guide. And that's all I've got.
We have one question, time for one question. Anyone? There's one over there.
Sliver, like pliable fast. Can you talk a little bit about that?
The sliver of the database.
Yeah, was that a offline store or online store?
No, it's just a word, like a small piece, a sliver. Yeah, sorry.
So maybe one more question.
Can you show, or maybe point me to GitHub later, the code on each end talk to the channel?
Yes. I'll show it very, very quickly. So I can do it super quick. So on the Phoenix side, we have the channels. So we have channel, and actually that's not right. Hold on a second. So in this case, we can look at like the store, no, where is it? So yeah, store channel. So basically, I just have this channel you can join called store fetch. If you ask to fetch the home data, it does some stuff, and then it sends it to you. That's it. And then on the Elm side, I think I'm running over. So we have the, really it's in the update. We have this thing down here that says home channel. Let's see, home channel. There we go. No, that's not quite it. Anyway, somewhere we have our channels that get mapped. This will be an app, sorry. So I have these channels. So I say, like, get the channels for the model. These might be some other channels I told about. And then get entity channels. So these are any channels that correspond to any entity in our database. Just map all of them to their channel. And then, like, connect with Phoenix. And then you're done. All of them emit the store message, which is just like that generic store update, so I don't have to do anything really smart. Like, as long as all those endpoints emit the same thing, then all I have to do is wire them up, and I'm done. Anyway, so that's that. And that's literally it.